I need to tell you about the project we've been working on with Colorado Biodiscovery Grants. And the title is The Use of Soluble Gamma Delta T cell receptors in Reducing Inflammatory Damage. So, in all vertebrates, there are three at least conserved types of lymphocytes. There are B lymphocytes, alpha beta T cell lymphocytes, and gamma delta T lymphocytes. And all vertebrates so far examined seem to have at least all three of these types. And the B lymphocytes have a receptor on their surface, which is also produced in a secreted form called antibody. And the alpha beta T cells also have a receptor on their surface, which is not secreted. But both of those receptors seem to be specialized to recognize foreign molecules. So if we get infected with a microbe of some sort, these are the cells that can detect that and get rid of those microbes. We are studying a different kind of T cell that's present in all vertebrates called gamma delta T cells, and these cells, we still are not really sure what they recognize, but we have a considerable body of evidence now that at least some of them are specialized to recognize stress-induced cell molecules, things that get turned on during infection, during inflammation. So the idea behind the project we wanted to do are as follows. First of all, the chronic or out-of-control inflammatory responses in some diseases cause tissue damage and destruction. And this is a big problem in a lot of diseases, but particularly in autoimmune diseases where there is no infectious agent really causing the disease. It's all being caused by an immune response going awry and causing tissue damage. So we know that there are different types of gamma delta T cells, and we've been studying these in my lab, and some of them produce different effects than others do. So we see distinct effects produced by different types of gamma delta T cells during inflammation. And we see that some types seem to increase inflammation, whereas other types seem to reduce it. So we also know that the receptor on the surface of these cells, which we showed you in the previous diagram, it's a cell surface receptor. It's the recognition of this receptor by a certain molecule that brings about the activation of the cell. So when it encounters its ligand for that receptor, the cell becomes activated and then can produce its effects. So we have some evidence that ligands for gamma delta T cells, as I mentioned before, are mostly, at this time, unidentified molecules that appear to be produced by our own bodies during inflammation. And so we had thought maybe there would be some way we could use this to control inflammation. So the project was to test whether by interfering with the binding of certain gamma delta T cell receptors to their ligands, we could potentially reduce inflammatory damage. And we've developed a novel way that will allow us, at least potentially allow us, to interfere with the responses of particular gamma delta T cells without even knowing what the actual ligands are. And to do this, we generated soluble forms of particular gamma delta T cell receptors. So this is just a diagram of how this is supposed to work. And this cell down here, I'll show you. Oh dear, this pointer just died.
No, it's there. You're just missing.
Am I just not aiming there? Yes, okay. So, my aim, I think I'm putting my finger in it. Okay, so this is supposed to be a macrophage, which is one T cell, which is one cell type that we've identified that seems to express molecules that appear to be ligands for at least some gamma delta T cells. And we've been studying this largely in the mouse. So macrophages, when they become activated, produce certain molecules, which are depicted by these little green things that are shown here, which appear to be ligands for particular gamma delta T cell receptors. And in the mouse, we have been studying a particular type of gamma delta T cell that we call V gamma 6 V delta 1. And it seems to recognize something that's expressed on the surface of macrophages during inflammation. And these cells bear a particular receptor. So what we have done is we've generated a soluble form of this receptor that we can make artificially in the lab, that we can produce by recombinant DNA methods in the lab. And we can make a lot of this. So the idea is to sort of flood the system with the soluble form of this T cell receptor so that there's more of that around than would be present on the normal gamma delta T cells bearing that receptor, so that they never get a chance then to recognize this ligand. So it's really a very simple idea. And we thought if we did this, we could block the response of these cells and then alter the resulting inflammation that occurs in the animal. So the advantages of doing this is that it's very highly cell specific. So we would be affecting only the response of one type of gamma delta T cell. So I think most drugs that are currently in use for altering the inflammatory response are pretty non-specific. They don't focus on just one cell type. They mostly focus on soluble mediators of inflammation. And so you have a very overall effect, which is not always a good thing. For instance, you may be having an arthritis flare-up and you want to reduce that inflammation, but that may leave you open then to an influenza infection which you may not handle very well if you're doing that sort of thing. So we would hope to avoid that sort of thing in this method. So also it would be very highly localized because the response would only be affected at the site of inflammation, because that would be the only case, the only place where those ligands would be expressed. So preventing the response of a cell type we also think could be actually more potent than blocking a soluble inflammatory mediator, because it occurs earlier in the process. So we have cells that produce soluble mediators that affect cells which produce other soluble mediators, and so there's this sort of cascade effect. So if we blocked that sort of early on, we might reduce the whole thing more potently overall. So anyway, that's the idea. Using a gamma delta T cell receptor whose ligand was already known, and there are not very many of these, but we did have one that was available, we were able to show that our soluble gamma delta T cell receptors are indeed capable of binding to the ligands. So what I'm showing here is one of those known ligands. It's a molecule called T22, which is expressed in this particular cell. It's been transfected, the gene encoding that molecule has been transfected into a cell line. And this yellow histogram that you're seeing here is the brightness of staining of a soluble multivariate version of a particular receptor that sees that particular molecule. And the other two lines that you see here, the green line and the pink line, are two other unrelated receptors. One of them is this gamma 6 delta 1 receptor that I mentioned before that we know is the ligand for that one is appearing on macrophages during inflammation. And it does not seem to recognize this particular molecule on the cells. However, that receptor, as well as another one, does seem to recognize something that's expressed on the surface of certain other cell lines. And we've actually found a lot of other cell lines that express this kind of constituent protein. This is one, it's called XB2, and it's just a keratinocyte line. And the other receptor that is called here the KN6 receptor, which sees this T22 molecule, doesn't seem to pick up anything at least nothing very strong that's expressed on these XB2 cells. So we think we're seeing here very specific staining. So the experiment we wanted to do for this grant is as follows. We are going to inject purified gamma 6 V delta 1 soluble T cell receptor into mice that we've infected with an infectious agent, Listeria monocytogenes. So we've studied this particular infectious agent quite a bit in the lab, and we know that it very strongly induces a response of V gamma 6 V delta 1 cells in the mice several days after the infection. So we want to see if we can then prevent the response of these V gamma 6 V delta 1 cells very specifically with this treatment. So we're going to look at the numbers of cells that we get following the infection in mice that have been treated with this receptor versus mice that have been treated with a negative control receptor. And we had planned to use here the KN6 receptor, which does not seem to recognize anything on these macrophages. So then if we find that this works, we plan to go on to see if we actually can show that this affects inflammatory damage in mice. If we can look at things like liver lesions, for instance, that often result in mice that have Listeria infection. Those could be reduced if we blocked the response of those cells. So this is currently in progress, and this is our very first result. And this is as far as we've gotten, and it's unfortunately very negative, as you can see. So we're looking at treated versus untreated, and I'm just showing you the percents of gamma delta T cells of various types that appear in these mice. And I didn't show you untreated mice, but normally this particular type, gamma 6 V delta 1, is very rare in these particular sites. So this is peritoneal exudate cells, which is one area where we see a very strong response of gamma 6 cells. And we also looked at the spleen, where you see a very strong response, and you see a high infectious level by Listeria. in these mice as well. So as you can see, that the VGAM6V delta 1 cells were quite well induced in the peritoneum. Whether we treated or did not treat with the soluble T cell receptor, they were very much the same. There's no significant difference between these two. And the same was true for all of the other types of VGAM delta T cells we looked at. VGAM1 positive, VGAM4 positive, and in the spleen, the VGAM6V delta 1 positive cells, which we looked at there too, also had become much more prevalent and didn't seem to be affected at all by whether we treated them. So our results so far look like it isn't working. But we were somewhat encouraged because at least there was nothing negative. So we were really actually very worried about doing these experiments at the beginning. We thought our receptor might actually kill the mice if we couldn't get it clean enough. We grow this in a baculovirus system, and we know there's stuff in that system that can provoke an extremely strong inflammatory response. So we needed to get this stuff very clean. So it looks like we at least succeeded in doing that, and we didn't put anything bad in it that made things worse. So sort of a limited success. We're going to go and try it again a couple more times. We're going to try using a higher dose of the soluble T cell receptor. We're going to try administering it at a different time point. It could be if you time this just so it works better. And the other thing we really want to try is multimerizing the soluble TCR, which should greatly improve the affinity it has for its ligand, and it might make it a much more potent reagent. So we think these soluble T cell receptors actually have potential for use in disease management, and could be something that might be worth further developing as a pharmaceutical. And we think that the use of a T cell receptor rather than an antibody to block the ligand could be actually a good idea, because it may ensure that cells that express low levels of the ligand are not affected at all. We do know that for some of these ligands, we see a low level expression naturally on a lot of cells, and it just gets induced to higher levels. So we're thinking because the affinity of TCR is usually lower than an antibody, we might not disturb cells that are not in an inflammatory state. And so again, we're to thank the state of Colorado and National Institute for their support.